As I was saying before, part of the reason we use base 10, and base 10 shows up on slide rules, is because it's very easy to do calculations with it. What we have when we do a base 10 logarithm is two parts. One part is out front, which I'll talk about in just a moment, and the other part is what we call the mantissa. If we evaluate log base 10 of 2.74, let's go ahead and do that, we get this number. This part to the right of the decimal is what we call the mantissa. And if we go ahead and take the same three numbers, 2.74, I just moved the decimal over one place here, 27.4. Again, we get the same mantissa, different number out front. Go ahead and move the decimal one more place over. Same mantissa, and you may be able to see a pattern here. This number out front denotes the order of magnitude. Right, and so you can probably assume that if you see 274 with the decimal in this place right over here, 2,740, that we're going to have 3.437. And indeed we do. However, what happens if we don't move the decimal to the right, instead we move the decimal to the left? Well, if you take a logarithm of, it doesn't matter what the base log is, if you take the logarithm of 1, you're always going to get 0. So if we take the logarithm of something less than 1, what happens? We get negative number, which is not the same mantissa as we had before. However, if we can figure out whatever this new mantissa is, if we can figure that out, then it doesn't matter if it's the decimal is moved only one place over or if it's moved 3 places over. Alright, again, we're keeping track of the magnitude. It's just a different mantissa that we have here. Well, the slide rule doesn't have the ability directly to give you these negative mantissas. However, we can do a little trick. And that trick is this. If we know that 10 to the x is equal to a, then that means that the log of a is equal to x. Right? That's the relationship between these two functions. You take the log of both sides of this, and on this side you have x, and on this side you have log of a. Well, there it is. If you let x equal 0, right, as I was saying before, if you take 10 to the 0 power or any base to the 0 power, you're always going to get 1. So the log of 1 is always going to be 0. And so we have that a is equal to 1 in this case. Well, what happens if a is less than 1? Well, that means we have negative x. So for negative x, we have that 10 to the x is equal to 1 over 10 to the absolute value of x. Well, that's a property that if you have a negative exponent, it's the same as the reciprocal of the positive exponent. Right? And I go ahead and take the reciprocals of both sides here. In other words, I just flip it around, so I have this. Right? And since I know that 10 to the x is equal to a, as I said before up here, 1 over 10 to the x is equal to 1 over a. Therefore, I can say 1 over a is equal to 10 to the absolute x. And with that relationship, for negative values of x, I have this. Logarithm of 1 over a is equal to the absolute value of x. So where on the slide rule I was only supposed to get positive values over here, now I can get a positive value just by taking the reciprocal of a number that I know is going to give me a negative value. And we can go ahead and try that. I'll take the log base 10 of 1 over, and I knew my numbers were 274, except they're on the wrong side of the decimal. They're here, 274, right? And this should give me positive 0.562. There you go.